All right, so let's look at some more examples of using counting techniques. Now, automobile license plates in Louisiana consist of 3 letters followed by 3 digits. How many different automobile license plates are there in Louisiana? And which is greater in number? License plates with distinct letters and digits, or those in which at least one letter or digit is repeated? Now, I want you to speculate first and then do the calculations below in order to make that comparison. So what I want you to do is to think about this second question here. Go ahead and stop the video for a few minutes and just think about this and see if you can come up with an answer to this. Which is greater in number? License plates with distinct letters and digits, or license plates in which at least one letter or digit is repeated? Now, we're going to be counting or doing several calculations in order to answer these questions. Obviously, we're going to first count the number of the total number of license plates possible in Louisiana. We're going to calculate how many automobile license plates there are that contain at least one repeated letter or digit. We're going to calculate the number of automobile license plates that have distinct letters and digits, and then we'll be able to make the comparison once we have those two numbers. Okay, so the first question is, how many different automobile license plates are possible in Louisiana? Now, to answer this question, let's consider the process of constructing a particular license plate. Now, this can be done in 2 overall steps. The first step would be to select the letters for the first 3 positions on the license plate. All right, and keep in mind that the order of those letters makes a difference. It matters. The second step, once we've selected the letters for the first 3 positions on the license plate, the second step would be to select the digits for the last 3 positions on the license plate. Now, each of these 2 overall steps can be broken down further into 3 steps. And so breaking down step 1, again, step 1 is select the letters for the first 3 positions on the license plate. And so the first thing we would do in doing that would be to select the letter for the first position. And so there would be 26 ways of doing this. Now, regardless of what letter we choose for that first position, because we're not imposing any constraints here, we're looking at the total number of possible license plates. And so there are 26 ways to choose the letter for the second position as well. And then regardless of what letters we've chosen for the first 2 positions, there are 26 ways to choose the letter for that third position. And so by the fundamental rule of counting, the total number of ways that we can perform step 1, which is selecting letters for the first 3 positions on the license plate, is 26 cubed. 26 times 26 times 26. Now, step 2, selecting digits for the last 3 positions of the license plate, can be broken down into 3 steps as well. So the first sub-step, step 2a, would be to select a digit for the for position 4. And there are 10 ways that could be done. There are 10 digits, 0 through 9. Right? So 10 ways to select that first digit. Step 2 would be to select a digit for the position 5 on the license plate, or the second digit position. There are 10 ways to do that. And then finally, for the third sub-step, there are 10 ways to select that third digit as well. And so by the fundamental rule of counting, step 2 can be done in 10 cubed ways, or 1,000 ways. And so combining these 2 overall steps and the number of ways that each overall step can be performed, by the fundamental rule of counting, there are 26 cubed times 10 cubed, or 17,576,000 different license plates possible in the state of Louisiana. Okay, now let's look at the question, how many automobile license plates are there with distinct letters and digits? Now, let's again think of constructing such a license plate, and we can think about this again in terms of 2 overall steps. Step 1 would be to select distinct letters for the first 3 positions on the license plate, And then step 2 would be to select distinct digits for the last 3 positions on the license plate. Now, again, each of these two steps can be broken down into 3 sub-steps. So breaking down step 1, which again is selecting distinct letters for the first 3 positions on the license plate. We would first select a letter for the first position. There are 26 ways to do that. Now remember that the letters in this case have to be distinct. So once we've selected that first letter, there are 25 ways to select that second letter. And then once we've done that, there are 24 ways to select the letter for position 3. And so by the fundamental rule of counting, step 1 can be done in 26 times 25 times 24 different ways. Step 2, selecting distinct digits for the last 3 positions on the license plate, can be broken down into 3 steps. The first of these steps would be to select a digit for position 4 on the license plate, which is that first digit position. There are 10 ways to do that. And then once we've selected that first digit, because the remaining digits have to be distinct, there are 9 ways to select that second digit. And then once we've selected the first 2 digits, there are 8 ways of selecting that third digit. And so by the fundamental rule of counting, there are 10 times 9 times 8 ways of selecting distinct digits for the last 3 positions on the license plate. And so then combining those 2 steps and the number of ways that each of those 2 overall steps can be performed, by the fundamental rule of counting, the number of ways that we can construct a license plate that has distinct letters and distinct digits is 11,232,000. Okay, so now let's look at the question, how many automobile license plates are there that contain at least one repeated letter or digit? Now, note that a license plate either consists of distinct letters and digits, or it has at least one repeated letter or digit. Therefore, the total number of license plates is equal to the sum of those 2 numbers, the sum of the number of license plates with distinct letters and digits and the number of license plates with at least one repeated letter or digit. Therefore, the number of license plates with at least one repeated letter or digit can be obtained by subtraction. We subtract 11,232,000 from the overall number of license plates, which was 17,576,000. And so that gives us, for the number of license plates that have at least one repeated letter or digit, being equal to 6,344,000. So to answer the question, which is greater in number, license plates with distinct letters and digits, or those in which at least one letter or digit is repeated? So again, the number of license plates with distinct letters and digits is given by that formula. Let me back up a second. So in order to make the comparison, so what we're saying here is that the number of license plates with distinct letters and digits is much more than the number of license plates containing at least one repeated letter or digit. In fact, the number of license plates with distinct letters and digits is 4,888,000 license plates more than the number of license plates containing at least one repeated letter or digit. Now, is that what you expected, or is that surprising to you? I think that if we don't think about this carefully, we may, when we first speculated, it may have been tempting to think that that there were more license plates with at least one repeated letter or digit, but it turns out that that's certainly not the case. In fact, the number of such license plates is a lot smaller than the number of license plates with distinct letters and digits. So one of the things this shows, beyond how to use counting techniques, is that we really do have to think about these kind of problems carefully and do the calculations in order to answer these kinds of questions accurately. One of the other things that I would point out, and I'm sure you're getting this sense, is that we are using the fundamental rule of counting all over the place, right? So even though we're only looking at 3 counting rules, there are more obviously, but we can answer a lot of questions using the fundamental rule of counting, using the permutation rule, and using the combination rule. Okay, so again, just to summarize, the number of license plates containing distinct letters and digits is 11,232,000. The number of license plates containing at least one repeated letter or digit is only 6,344,000. Now, I also ask you to think about this. Which of these would you consider to be the easiest to compute directly? And when I say directly, what I mean is using the counting principles. Notice that in order to get the number of license plates that have at least one repeated letter or digit, we obtain that via subtraction on this slide. So I think you would agree that it was fairly straightforward to calculate the total number of possible license plates, and it was equally straightforward to calculate the number of license plates that have distinct letters and distinct digits. But it would be very difficult, very cumbersome, very tedious to, at least in my view, to compute the number of license plates with at least one repeated letter or digit using counting techniques directly. It's much, much easier to get this value by subtraction once we've calculated each of these 2 values. Okay, moving on to the next example. Consider dealing a 5-card hand from a well-shuffled standard 52-card deck of playing cards. And so the questions that we want to consider in this example: how many different 5-card hands are there? What is the probability of being dealt a full house? And what is the probability of being dealt a 2-pair hand? So the first question, how many different 5-card hands are there? Now to answer this, let's consider the process of selecting 5 cards without replacement from a standard deck of 52 playing cards. All right, so the deck has 52 cards. We're selecting 5 of those cards without replacement. The order that we obtain the cards does not matter. This is not an arrangement of cards. It's a combination or a subset or a collection of cards. And so the number of ways that that can be done is 52, choose 5. All right? And there's only one step in this process. Right? And so the total number of ways of selecting 5 cards without replacement from this standard deck of 52 cards is 52, choose 5, or 2,598,960 5-card hands. Now, when we say, let me go back to the first slide here. When we say that we're selecting the cards from a well-shuffled deck, what that means is that this is just a shorthand way of saying that the cards have been shuffled sufficiently so that all of these, all 2,598,960 5-card hands are equally likely. All right? And so that is what we mean when we say well shuffled. They're shuffled in such a way and to such an extent that all of these possible hands are equally likely. Now this just shows the calculation, 52 choose 5, on the TI-84 calculator. And so now we'll look at the second question. What is the probability of being dealt a full house? Now to answer this, we first need to determine the number of full house hands that exist. And so to do that, let's consider the process of selecting or constructing a full house hand. Now, what is a full house hand? We need to know that, right? So recall that a full house hand is a 5-card hand in which 3 cards belong to one rank and the remaining 2 cards belong to another rank. So for example, you might have 3 cards from jacks, and you might have 2 cards from the rank of 5s. Okay, that would be an example of a full house hand. Another example would be to have 3 aces, so 3 cards from the aces rank and 2 cards from the king's rank. That would be another example of a full house hand. And so the process of selecting or constructing a full house hand, we can think of this as a 4-step process. The first step would be to select the suit, which we'll call suit 1, from which we're going to select 3 cards. Now there are 13 suits overall to choose from, and so the number of ways of selecting that one suit is 13 choose 1. Step 2, once we have suit 1 selected, step 2 would be selecting 3 cards from that suit. Now there are 4 cards within the suit, and so the number of ways of selecting 3 cards from that suit would just be 4 choose 3. Again, because order does not matter, all right? So 4 choose 3 would be the number of ways that we could perform step 2. Once we've done those 2 steps, the third step would be to select another suit, which we'll call suit 2, from which to select 2 cards. Now, we've already selected the first suit, so that we can't select that one anymore. So there are 12 remaining suits to choose from. And so the number of ways that we can perform step 3 is 12 choose 1. Once we've done step 3, once we've chosen that suit from which we're going to obtain 2 cards, the last step, step 4, would be to select 2 cards from that second suit. Now again, there are 4 cards in that suit to choose from. The order that we select the 2 cards does not matter. And so the number of ways of doing that would be 4 choose 2. And so by the fundamental rule of counting, the number of full house hands is given by 13 choose 1 times 4 choose 3 times 12 choose 1 times 4 choose 2. Now 13 choose 1 is 13, 4 choose 3 is 4, 12 choose 1 is 12, and 4 choose 2 is 6. So when you multiply those together, you get 3,744 different full house hands. And so then the question, what is the probability of being dealt a full house from a well-shuffled deck of cards? And again, when we say well-shuffled, what we mean is that the cards are shuffled sufficiently so that all possible hands, all possible five-card hands are equally likely. And so in that context, where the sample space consists of equally likely events, the probability of this event is going to be the number of ways that the event can occur. Well, that's equal to 3,744 different ways of being dealt a full house hand. Then we divide that by the total number of possible hands, which was 2,598,960. And so that gives us a probability of 0.00144406. So pretty doggone small. The final question, what is the probability of being dealt a 2-pair hand? Well, to answer that, we first must determine the number of 2-pair hands that exist. And to do that, let's consider the process of selecting, or again, constructing a 2-pair hand. Now again, let's remind ourselves of what a 2-pair hand is. So recall that a 2-pair hand is a 5-card hand in which 2 cards belong to one rank, 2 cards belong to a different rank, and then 1 card belongs to yet a third rank. Right? So that's the definition of a 2-pair hand. And so we can think of the process of selecting a 2-pair hand or of constructing a 2-pair hand. And we can think of this, we can break this down into 4 steps. Step 1, now this is slightly different than the constructing a full house hand, and I want you to think about why that is. Step 1 would be select the 2 ranks from which to select the 2 pairs. So again, we're constructing or selecting a 2-pair hand. We need to have pairs from 2 different ranks. And so the first step in doing this is to select the 2 ranks from which to select the 2 pairs. Now again, there are 13 ranks to choose from. We're selecting 2 of those ranks from which we're going to get pairs. And so the number of ways that we can perform step 1 is 13 choose 2. Once we've done that, then we need to select 2 cards from one of the ranks, all right? And there are 4 choose 2 ways of doing that. Then we need to select 2 cards from the other of the ranks that we selected, and that also is 4 choose 2. All right, and then the next step, we need to select the rank from which to select 1 card. Once we've selected 2 ranks up in step 1, there are 11 ranks left. We're only going to select one of those ranks. And so that the number of ways of doing that is 11 choose 1. Now I said that there are 4 steps. There's actually 5 steps, and that 5th step is on the next slide. So once we've done the first 4 steps, once we've selected in particular, once we've done step 4, we've selected the rank from which to select a single card. It remains to select that single card from that rank. And the number of ways of doing that is 4 choose 1. And so then we can invoke the fundamental rule of counting, all right, and apply it by multiplying the number of ways that each of these 5 steps can be performed. And what we get is 123,552. So that is the total number of possible 2-pair hands. And so what is the probability of being dealt a 2-pair hand? Well, because the deck has been well shuffled. Again, what that really means is that all possible 5-card hands are equally likely. And so the probability of this event, of being dealt a 2-pair hand, is equal to the number of ways that could occur, the 123,552, divided by the total number of possible hands, 2,598,960, which gives us a probability of 0.047539, so almost 5%. So getting a 2-pair hand is much more likely, much more probable than getting a full house hand. So this is a good place to stop this video, and we'll pick up with some more examples in the next lecture video. So I'll see you there.